Hello everyone. Data is at your core of your use of Geographic Information Systems or GIS software. Working with data is one of the most fundamental concepts and tasks you can master with GIS, such as understanding spatial queries, table joins, and relates. If you want to learn more about spatial queries, table joins, and relates, then this video is for you. In this video, I'll teach you about what spatial queries are, and then I'll tell you about the very important concepts of table joins and relates. Then, using a hands-on demonstration with the ArcGIS Pro software from Esri, we will compare and contrast various spatial querying, joining, and relating techniques so you can see how these techniques play out in action. Ultimately, I hope through this discussion, it will help you grow your GIS skill sets. Perhaps the most fundamental concept you need to understand is the idea of a query. A query is the basic idea of asking a question of a data set. Queries are very common to data management in general and are not solely restricted to GIS applications. Understanding how to do queries in a GIS context is perhaps one of the most fundamental skills you can learn, as you will then be able to ask questions of your data and get potential answers to help you with problem solving, decision making, and analysis. There are many ways to query data in GIS. And in just a few moments, I'll give you a hands-on demonstration of some of those querying methods. Before we proceed with the demonstration, I want to cover some basic concepts about queries. Tables of rows and columns are the foundations of queries. In this image, you see a table of US states. A query to this table uses a very specific syntax called SQL, or Structured Query Language, that I'll talk more about in just a moment. Here, however, you see an example of a basic SQL statement. Although this may look intimidating at first, SQL statements are in fact quite simple once you learn how the language works, just like learning to speak a foreign language. For example, the first half of the statement is simply asking for every record from the table as indicated by the star character. The second part of the statement is asking for the query to only return records where the value of the state column is equal to the term Alaska. When this query runs, only records from Alaska will be returned. Structured Query Language, or SQL, is a vast topic unto itself. Many people make a living as database administrators due to their ability to master the use of this query language. SQL statements are used both explicitly and implicitly in GIS software. This image shows a more complex example of what SQL can do. This statement is looking to get a count of authors by book title. This statement is using the concept of a join. This means that two tables are being combined to get one output. I'll talk more about joins in just a few moments. The output of this query is shown in this figure. I'll next talk a little bit more about the SQL where clause, as these are very common in the use of desktop GIS software. SQL contains a number of what are known as where clauses. You saw a quick example of a where clause a few moments ago when I showed you the basics of a query that only selected records with the value of the state where the field was equal to the term Alaska. However, many more types of where operators or ways in which you can determine the specific criteria of a query exist. This image shows a variety of where operators for SQL. For example, numerical values can be determined using greater than, less than, or equal. GIS is unique in that it contains what are known as spatial query operators that look at the spatial relationships for determining results returned from a query. In the next slide, I'll talk more about spatial query operators. Another way to think of spatial query operators is that of a spatial where clause. This image shows a select representation of spatial query operators that are common in GIS. Intersection is a very commonly used spatial operator. For example, note how this line is intersecting a polygon, and this is how the polygon could be selected using a spatial query. I encourage you to study spatial query operators to develop your own spatial thinking skills that can ultimately enhance your analytical ability for working with geographic information. In this next part of the video, I'll give you a hands-on demonstration of working with query tools in the industry standard desktop GIS software ArcGIS Pro. In particular, I'll show you how to use the Identify tool, select things using a graphic, how to select items using the Select by Location tool, how to run a query using the Select by Attribute tool, and I'll follow that back up by showing you the very handy Definition Query tool. Okay, let's start with showing you the Identify tool. This is perhaps one of the most fundamental tools you'll use in ArcGIS Pro. The Identify tool is combined with map navigation. So what I mean by that is if I've selected Map and Explore, the Explorer tool allows me to pan and zoom around the map. So if I'm holding my left button down, I'm panning. If I use my mouse wheel, I'm zooming. And notice when I'm not pressing the button at all on my mouse, the mouse cursor looks like a hand with a pointer. And so when I left click on one of the shapes in the map, notice how it turned blue, and then over here on the right, a pop-up window came up. And this is giving me the attributes for the map feature that I clicked on. And this is a really great way that you can interactively explore with the map. Next, let me show you how you can select features using a graphic. Now, this can be a really great way to visually select features, and it's particularly useful as you start to explore a data set. To select a feature with a graphic, make sure that you've selected the map menu and you have the map ribbon. And under this menu here, where it says select, if you click the drop down, notice you get a bunch of different geometries you can use. So in this case, I might be interested in selecting counties that are on the border between these two states. The state in orange is called New York and the state in yellow is called Pennsylvania. So to use the select by graphic, I've selected the tool and I'm going to just start clicking on those areas, and notice how I'm getting what they call a rubber band is showing up. And every time I left click, I get another point. And then when I double click, I get the features I'm interested in as shown by the blue. And if I were to look at the attribute table of the counties, and I can click this button to look at just the selected records, you'll notice that I have a mix of counties that were selected in New York, NY, and in PA. So again, the Select by Graphic tool is a great option when you want to interactively and explore features on your map, making selections using some kind of a graphic. Okay, let's next go over the Select by Location tool. Select by Location is one of the most fundamental tools that's been in GIS software for a very long time. To run a Select by Location, select the Map menu and the Select by Location tool inside the Selection group, and then use this dialog to make your selection. Now in this case, I'm interested in selecting cities shown by these red dots that are completely within the counties of New York State, which are these orange polygons shown on the map. And to run this, you select the input features as cities. And this is now where you're going to see some of those spatial relationships I talked about earlier in the video. So I want cities that are completely within the New York counties. And we'll make this a new spatial relationship. And when I run this, notice how I have two blue dots that represent the selected features, because these dots were completely within the New York counties. And this is a great example of using those spatial relationships and query operators, like I said earlier. And if I look at the attribute table for the cities, as a reminder, if you click this button here, you can see that 2 out of the 606 cities that were in this data set have been selected. In this case, Rochester and Buffalo. So select by location is a great option for when you really want to look at the spatial relationships between different data sets. Next, I'll show you the Select by Attributes tool. If you're interested in SQL, the Select by Attributes tool gets you started on actually writing SQL statements if that's something you're interested in. You can access this tool from a couple of locations. It is available under the selection group here, but here's the way that I like to do it. When I'm going to do a select by attribute, I often open the attribute table of the data set I'm working with. You can see here that the select by attribute table is also available. When I click that button, I get one of these standard dialog boxes. Now, just as a side comment, Esri software for a very long time has tried to hide coding away from its users. And I think they do this because they think perhaps it's too hard for people to write SQL statements. Maybe it is, but I would really encourage you to learn how to write SQL. Now, in this case, I'm going to do a query where I want to know about the population of females in the various census tracts. So to do that, I'm going to select New Selection, and I'm going to pick my field, and this drop-down box here is populated with the attribute columns of the data set down here. So in this case, I'm going to select females, and the operator, which in this case I want where the value is going to be greater than a numeric value of 2,500. Now, you might want to check that the syntax is correct. Green is always good. Now, to run the query, hit the apply button. And before I do that, just make note of the table in the map. When I hit the apply button, you can see that the records that were selected by this query come back as blue. And you can see that about 1,300 of 4,900 were selected. Now, if you're interested in actually writing a much more complicated query than this one, notice here that you have the SQL button. And this can give you a lot of options for writing queries that are more complex based on just selecting values from this Select by Attributes dialog box. As a logical follow-up to the Select by Attributes tool that I just showed you, another really handy use of an SQL where clause is what's called a definition query. A definition query is essentially a filter that you can put on a data set that modifies its display. For example, here you see how there is an orange polygon from New York State that is over Lake Ontario. This is the actual legal jurisdiction of New York State, but in a lot of cases, I'm not really interested in doing an analysis that shows this polygon layer. So what I'm going to do is run a definition query to visibly remove this feature from the map. So to do that, I'll use a couple of the tools I showed you earlier. First, I'll do an identify. I'm going to click on that shape. And notice here how it has a FID, feature ID of 1870. I'm going to copy that, or at least remember it, and then check this out. I'm going to go over to that data layer of counties. I'm going to right-click, Properties, and then I'm going to look for the Definition Query tool. and I'm going to define a new query. And you'll see that it has a dialog box very similar to the Select by Attributes field. In this case, I'm going to select where feature ID is not equal to 1870. This means that the map is only going to show features where the value of that attribute is not equal to that value. And the effect I'll get from this is that that polygon over Lake Ontario should go away. You can see here too, I've got my SQL if I want to use that. I can validate it and then I'll hit apply. And notice that that polygon over the lake is gone. So use definition query along with an SQL where clause to filter out features in your data sets. Another very important concept in GIS related to queries is that of a table join. This is another concept that comes from regular database management, but has been adopted into the GIS context due to the fundamental nature of data management when working with GIS data and software. The basic idea behind table joining is where two tables are combined based on a common field in both tables. For example, imagine that you have two tables related to land type. The first table contains the geographic features of land type polygons. The land type category in this table is referenced by a code. The second table contains the textual descriptions of the categories and the land type code. Thus, the two tables share the land type code field in common. This will allow the two tables to be joined to one another. Once the two tables are joined, a new combined table is created. This table contains the attribute fields or columns from both tables. Joining spatial features to attribute tables is a very common way for creating final map products. In the following part of this lesson, I'll give you a brief example of this idea. In this example, you see the same two tables you just saw. One is a table containing polygon geographic features of land types. The other table contains textual descriptions of the land type. Also, like you saw, the two tables share the land type code as a common field. When these two tables are then joined together, the combined attribute table can be used for making a more readable map. For example, if you look at this image, notice how the legend is showing the textual description of the land type as opposed to the land code. Displaying just the land code number would not be intuitive to the reader of the map. Therefore, it is important to use table joins when making a final map product that can have a more meaningful legend. Spatial joins are the idea of combining attributes from multiple tables based on the spatial relationships between geographic features of the tables. This idea is best explained visually, as I'll do in the next part of this video. In this image, you're seeing two geographic datasets. The first are wetlands, shown as blue polygons. The second are roads, shown as red lines. In this scenario, I'm interested in having attributes from the wetlands appended to the attributes of the roads. I might be interested in doing this to consider how the roads are spatially related to the wetlands for environmental impact. If we look at the attribute table for the roads, notice how I have the name of the road but nothing else. If I look at the attribute table for the wetlands, notice I have a wetland category code. The wetland category codes are also shown as numbers on the blue polygons on the map. When I run the spatial join command, ArcGIS Pro will create a new representation of the dataset based on the roads. As you can see in this new updated map, the roads created by the spatial join command are shown as a green line. When reviewing the attribute table of this new dataset, note how the table contains both the name of the road and the wetland category code, or a combination of the two previous tables that was created by spatially joining the tables together. One last important concept is the idea of a table relate. A table relate is the idea of defining a relationship between two tables. The important point here, however, is that the data is not appended to the layer's attribute table like a join. Relates are often used for what is known as a many-to-many relationship, or when many records in one table might be related to many records in another table. Additionally, relates can also be used for the very common one-to-many relationship. In the next part of this video, I'll give you a hands-on demonstration of relates in addition to table and spatial joins that you just learned about previously. I'll next show you how to do a table join. A table join is perhaps the most fundamental skill that you can learn with ArcGIS Pro in terms of data management and manipulation. I'm going to use the example I showed earlier in this video to demonstrate the concept. On the map here, you see a shapefile with polygons that represent land use. If I look at the attribute table of this data layer, you can see that I have the land use code as a number, but I have no textual description of what the land use actually is. Here I have a text file containing the land use codes and their textual description. I'm going to bring this over into my map, and you can see it comes in as a standalone table. If I open the land use codes and then put these two tables side by side with one another, you can see they have in common the LU code. So what I want to do is put these land use codes from this text file and join them onto the land use codes polygon feature layer. To perform the join, follow these steps. I'm going to right-click on the land use layer and select Joins and Relates and Add Join. In this case, the input table is the table that will receive the join. So as per the example, this is the table that I want the descriptions of the land use added to its attribute table. The input field will be the land use code, LU code, and the table that's going to send the data over to the other table is called the join table. Or as the pop-up says, the table view that will be joined onto the input table. And in this case, that field in common is the code. And you can do things like validate the join to make sure everything works okay and get some feedback. But then once I do that, if I hit OK, now when I open up the attribute table for land use, you can see here I've got these two extra columns that have been added because of the join. Now with that, I can start to use that table join to create a more meaningful map. So for example, if I were to go to the symbology and select unique values, all of the fields from the table join are now there if I selected description. And you can see here those descriptions coming from the table join are now appearing in the table of contents. That's what makes table joins so incredibly useful for enhancing a data set with different attributes you may get from another table. And I should also just briefly mention that when you're done with a table join, you can remove a join by doing the same process. Right-click, Joins and Relates, and remove all joins. And you can see here the attribute table updated where there's no longer the description from the joined table that came in. Let's now review a spatial join. As a reminder, a spatial join will append the attributes from one dataset onto the attributes of another dataset based on some type of spatial relationship that you define. This is different than the classic join that looks at the values of attribute tables in a common field. Now in this example, also drawn from the previous examples in this video, I want the attributes from these wetlands, shown in blue, to be added to the attributes of this roads dataset shown as this black line. If I look at the attribute table for the roads, I have the name of the road, its type, and so forth, but I don't have any of the information about wetlands that might be near those roads. So let's take a look at the attribute table for the wetlands. Now in this case, I do not have a field in common between these two data sets that I can use to perform the classic join. Therefore, I'm going to look at the spatial relationships between these two data sets in order to bring attributes from wetlands into the attribute table of roads. And as you can see here, this particular road is going very close to several wetlands, and I'll use that spatial relationship to my advantage in order to update the attribute table of roads. So to perform the spatial join, it's very similar in terms of how you access the tools the same way you did with a regular join. So in this case, I select roads, right click, joins and relates, add a spatial join. The target features are the roads. This is the layer that will receive attributes. The join features is the data layer that's going to send features over. And in this case, I have all of now of my spatial operations that I can select from to determine the spatial relationship between the two data sets. So in this case, I'm going to select within a distance, and I can define what that distance is. And in this example, I'll make it 200 meters. So what this means is if there's a wetland that is within a distance of 200 meters of a road, the attributes of that wetland will be sent over to the attribute table of the roads. I'll click OK to run. And if you notice down here, the attribute table of the roads has now been updated with attributes from the wetland layer. In some cases, the spatial join did not find a matching feature, as you can see here by the null records, but in many cases it did. So if I look at one example, I'll click on this row here, and then to find that, I'll right click and do zoom to. And you can see here that this particular road was very close to this wetland. So this wetland with a wet ID of 6 in class 1 was next to this road. And again, using my identify tool that I showed you earlier in this video, just to confirm that when I click on this blue shape here, here's a wet ID of HM6 and a class of 1. So the attributes from that wetland were spatially joined onto the road. Finally, let me show you a relate. A relate can be a very handy data querying and management tool when you have one-to-many relationships between given data records. In this example, we'll do a relate between National Register locations, shown as the red dots on this map, and New York counties. For those of you not familiar with these things, National Register locations are sites of important historical and cultural significance in the United States. Now, if I look at the attribute tables of these two layers, you can see that each county is identified with a numeric code. And I will look at the National Register locations. And again, I put these tables side by side. You can see here that the National Register locations have a county code. And if I were to sort these by ascending, you can see, like in this example, there are numerous records for this particular county. This is what's called Albany County. And you can see I have a couple blue points. I didn't select all of them. So basically I have one county shown now in the blue to many of these records over here in National Register. And that's a great example of a relate. One county has many National Register locations associated with it. So the table relate will make that relationship based on attributes in common. To set up my relate, I'll follow a similar process like I did a table join and a spatial join. I'll select New York counties, joins and relates, and add a relate. And as I showed you previously with the attribute fields, I'm going to use the county identification number, the National Register locations, and you can see that here, in this case, ArcGIS Pro found a field in common, and so it automatically selected it, even though I do have a lot of other options. I'll just keep the default name of Relate 1, and the cardinality. Here's the different cardinalities or relationships you can do. As I talked about earlier, this is a one-to-many, although you can have many-to-many. And if you're interested in these topics, I encourage you to read up more on database management. With that, I hit OK. Now, when you do a relate, you don't really see anything like the way you might do with a spatial join or a regular join in terms of things on the map, or really even in the attribute table. If I were to open the attribute table of New York counties, I don't really see anything, but you can see sort of what I might call the magic of the relate going back to the beginning of all this with the identify tool. Now with the relate active, when I click on Albany County, which is where my mouse is, let's take a closer look at the pop-up window. Notice in the pop-up window 001, but now notice on the drop-down, I see the relate, the National Register locations, and I've got, according to this, 119. So what this means is there are 119 points inside of this particular county, or in this case, that are related. And this can be a really handy way to kind of manage your data and understand it. So you can use a lot of the same functions then for finding these records. You can see when I click on them, the individual attributes come up. And if you notice on the map, they're flashing when I click on them. And I can also use the standard zoom to and so forth. So keep relates in mind when you have one-to-many or many-to-many relationships between data sets. So let's review what you've just learned about in this video. I showed you how to describe what a spatial query is in terms of SQL statements and spatial query operators. You also learned how to describe what table joins and relates are. And remember that table joins are a core GIS concept that will allow you to work with a wide variety of spatial and non-spatial data sets in GIS. Finally, I showed you how to compare and contrast various spatial querying, joining, and relating techniques using practical demonstration using ArcGIS Pro software. These are key skills that you can develop. As you saw, performing joins and relates is not difficult. However, it is important that you master the concepts and techniques behind these skills so that you can use them effectively when working with GIS. Hi, this is Brian Tomaszewski. If you enjoyed this video, be sure to like, comment, and share this video. Also, please consider subscribing to this channel and clicking the notification icon to stay up to date on new videos from this channel. Thanks for watching.